Welcome to this explainer on an absolute legend of the skies, the Boeing B-52 Stratofortress. We're diving into a genuinely staggering dual narrative today. On one hand, it's this monumental engineering triumph, right? An aircraft that just continuously evolves to stay relevant and refuses to quit. But there's a darker, very real story here too, about the immense human and mechanical costs of flying an aging behemoth for decades on end. It's a fascinating look at the absolute limits of design, human endurance, and the rigorous, sometimes painful lessons learned from pushing the envelope.
Okay, let's dive into this. Just think about this for a second. The absolute youngest B-52 currently flying was delivered back in 1962. That is, before the Cuban Missile Crisis, before the first man even walked on the moon. We're talking about machines that were rolling off the assembly line before personal computers even existed. These structurally robust but undeniably old airplanes have outlasted the original lifespans their engineers envisioned by more than half a century. It's just wild.
To understand how a plane even lasts that long, we actually have to go back to a frantic weekend in October 1948. So the initial concept in 1946 was this straight-wing aircraft powered by 6 clunky turboprop engines. But during that fateful weekend, Boeing engineers were holed up in a Dayton, Ohio hotel room at the Hotel Van Cleve. In just a few days, they completely scrapped the turboprop concept and pivoted to a radically new design, a swept-wing marvel powered by 8 turbojet engines. They literally built a scale model with hobby shop supplies and hand-drew the blueprints right there on a hotel desk. That design led to the maiden flight in 1952 and eventually the delivery of the final aircraft in 1962.
Over the decades, the B-52's mission has drastically evolved. Originally, it was built as the ultimate Cold War nuclear deterrent, designed to fly high-altitude standoff missions. But it completely transformed its identity based on the needs of the era. It eventually transitioned into a conventional bomb truck for precision strikes. And today, it actually plays a massive role in maritime dominance. A pair of B-52s can monitor 140,000 square miles of ocean surface in just 2 hours, laying quick-strike naval mines or carrying Harpoon anti-ship missiles.
Now, what's really interesting about this is how a 1950s airframe continually integrates cutting-edge smart weapons today. Through the Internal Weapons Bay Upgrade, or IWBU, the B-50 doesn't just strap bombs to its wings anymore. It uses a digital rotary launcher inside the belly to carry JDAM precision-guided bombs and advanced JASSM cruise missiles internally. By moving these weapons inside, it reduces drag, saves fuel, and maximizes its staggering capacity to carry up to 70,000 pounds of mixed ordnance on a single flight. Talk about a glow-up.
And man, it has put that payload to use. The operational history of this bomber spans major conflicts across half a century. It went from executing massive bombardment campaigns during Operations Arclight and Linebacker II in Vietnam in 1972 to delivering 40% of all coalition weapons dropped during the Gulf War's Desert Storm. Later, it adapted to provide high-altitude close air support over Afghanistan, all the way to neutralizing Iranian ballistic missile facilities and command and control infrastructure during Operation Epic Fury in early 2026. It has been a constant, looming presence across decades of shifting global conflicts.
To really grasp what that means for the crews, think about how exhausting a 10-hour commercial flight is as a passenger, right? Now, imagine taking off from Barksdale Air Force Base in Louisiana, flying all the way to Iraq to launch conventional air-launched cruise missiles, and flying all the way back to Louisiana, non-stop for 35 hours. That Desert Storm mission stands as the longest strike mission in the history of aerial warfare, pushing human endurance to the absolute limit.
And what is it actually like inside the aircraft during those grueling missions? Well, the B-52 features a split-level cockpit with severe temperature control issues. The pilots on the upper deck sit in a glass bubble heated by the sun, making them super prone to overheating. Meanwhile, the radar navigators sit in a windowless lower deck down by the ice-cold floor. If you adjust the climate control so the pilots are comfortable, the navigators freeze. If you warm up the lower deck, the pilots are roasting. The crew basically has to choose between a sauna and a freezer while flying a nuclear-capable bomber.
The psychological and physical weight of these long-duration sorties just cannot be overstated. Fatigue and complacency are massive immediate risks. In a 1960 training crash, a fatigued pilot literally blacked out mid-flight. It is a stark, urgent reminder that physiological factors and the grinding reality of high-tempo military operations can be just as deadly as mechanical failures.
Beyond human fatigue, the airframes themselves are absolutely exhausted. Over its history, more than 70 B-52s have been lost to accidents.
During the Cold War, the fleet shifted to low-level flying to evade radar, which subjected the wings and airframe to severe aerodynamic stress and flexing. Today, the reality of maintaining a 70-year-old fleet means maintainers frequently have to cannibalize spare parts from one bomber to fix another. It is genuinely amazing. They are literally scavenging parts for a multi-million-dollar military asset simply because the original manufacturers went out of business decades ago.
So, the crucial point is, because these airframes are so heavily stressed, treating the flight envelope, those precise engineer-defined boundaries on speed and maneuverability, as mere suggestions is a fatal mistake. In several tragic B-52 accidents, like a 2016 crash in Guam where a pilot over-rotated on takeoff, pushing past those boundaries has cost lives. The margin for error is essentially zero. Which brings us to a very solemn reality: 8. That is the number of personnel who tragically lost their lives during a B-52 test flight crash at Edwards Air Force Base in California's Mojave Desert in June of 2026. The aircraft plunged at nearly a mile a minute before impacting the ground. Understanding why this happened requires looking at the specific crew dynamics of that ill-fated flight. A standard B-52H operates with 5 highly synchronized personnel. But the June 2026 flight was testing a brand new Active Electronically Scanned Array, or AESA, radar system. To monitor the experimental telemetry, the flight operated with an expanded crew of 8. In a high-stakes emergency, as the plane rapidly lost altitude, suddenly having civilian engineers and private contractors in the mix introduced unique and tragically fatal communication breakdowns.
To make sure this never happens again, the military didn't just tweak the rules, they overhauled their safety culture, with 4 absolute mandates. First, strict adherence to flight envelopes. Second, continuous and highly realistic simulator training that perfectly replicates degraded aircraft states. Third, rigorous proactive maintenance to catch structural fatigue before it fails. And finally, enhanced crew resource management.
And this brilliantly illustrates how aviation learns from tragedy. Crew Resource Management, or CRM, focuses directly on improving communication, situational awareness, and problem-solving among everyone on board. CRM isn't just military jargon. It's a system now used in civilian hospitals and corporate teams to ensure that when a split-second, life-or-death decision is needed, everyone knows exactly who makes the call, which is especially critical when non-standard crews of engineers and contractors are involved.
Looking to the future, addressing the mechanical risks of the B-52 is the goal of the massive and honestly incredibly exciting Commercial Engine Replacement Program. The aircraft's old Pratt & Whitney TF-33 engines, based on 1960s tech, have become increasingly unreliable and, as we've seen, nearly impossible to find parts for. The solution is replacing them with modern Rolls-Royce F-130 turbofan engines. This upgrade is such a massive leap forward that aircraft receiving these new engines will actually be officially redesignated as the B-52J.
Let's move to and see how this builds, because this raises a really interesting engineering question. If you're putting on powerful modern turbofans, why keep the iconic 8-engine design? Why not just use 4 bigger ones? Well, the truth is, retrofitting the aircraft's massive rudder and altering the legacy flight control systems to safely operate on 4 engines is simply too complex and way too costly. It's actually much safer and more efficient to stick with the original 8-engine pod layout envisioned back in that Dayton hotel room.
The end result here is that the B-52 is being systematically transformed into a modern marvel, meant to fly alongside next-gen stealth bombers well into the 2050s. The sheer absurdity of that timeline is just breathtaking. Between the new Rolls-Royce engines, the advanced AESA radar for vastly improved targeting, and entirely modernized crew compartments and avionics, the Stratofortress is being positioned not as a relic, but as a vital complement to the Air Force's newest stealth bomber, the B-21 Raider.
Which leaves us with a fascinating philosophical question to end our explainer today. As the B-52 flies towards its 100th birthday in the 2050s, it has swapped out its nuclear deterrence mission for conventional precision strikes. It has swapped its old mechanical radars for digital ESA systems. It has swapped its original turbojets for modern turbofans. Like the ship of Theseus, if you replace almost every single part over a century, what truly makes it the same aircraft that those engineers sketched out on a hotel desk in 1948? It's an incredible testament to the enduring genius of its original adaptable design. Thanks for joining us.